welcome to Gifted and Science and Technology Physics class. I'm NC Joshua, popularly known as Oracle. Today we'll be looking at density. What is density? Density is the mass per unit volume of a substance. Density is mass per unit volume of a substance. So the density of a substance can be determined by the mass per unit volume of that substance. Now, what is mass? Mass is the quantity of matter a substance contains. That's mass. And what's the SI unit of mass? The SI unit of mass is kilogram. Now remember, there are various substances that can be used to measure the mass of a substance. You have, for instance, the beam balance. It can be used to measure the mass of a substance. Now remember that the mass of a substance everywhere is the same. The mass of a substance do not change with location, but the weight of a substance varies with location. What is weight? Weight is the gravitational pull of the earth on an object. So because the gravity varies, so also the weight of the substance varies. But the mass of a substance do not vary with location. Remember, mass is a measure of inertia. Mass is a measure of inertia. Now, so we'll come back. What is volume? Volume is the space occupied. That's volume, the space occupied. So if density is mass per unit volume, we use rho to represent density. Rho is equal to mass over volume. Therefore, what's the SI unit of density? SI unit of density is kilogram, that's mass, then per meters cube. Kilogram per meters cube, that's the SI unit for density. One thing you must note is that density is a scalar quantity. Density is a scalar quantity. It's not a vector quantity, it's a scalar quantity. There are other kinds that are related to this. We have something like energy density. Energy density. We have this word, energy density, which is energy over volume. We have energy density, which is energy over volume. And I have another that is current density. Current density. Current density is current over area, not over volume. Current over area, not over volume. But energy density is energy over volume. Now, why? Because energy flows in 3 dimensions, but current flows in 2 dimensions. That's what you hear about the cross-sectional area of a wire. So that's why we are using over area and not over volume. So take note, this is density, but this is energy density, and this is current density. So what is the SI unit for energy density? Energy is in joules, volume is in meters cubed. So it's joules per meters cube. What about current density? The SI unit for current density will now be current in ampere, ampere per meter square, ampere per meter square, because area is in meter square, but volume is what? In per meter square. Sorry, per meters cube. So what's the next thing I want you to know about density? Density will have what we call relative density. Relative density. Relative density is a comparison. It's a comparison between density of various substances. For instance, solids and liquid can be compared with the density of water, but density of gases can be compared with density of air. So what is relative density? Relative density will now be giving us the mass, the density of the substance first, the density of the substance raised over the density of water. Relative density, if it's a solid, it will be the density of the solid. So the density of water, that's relative density. What about that relative density of a solid? What about relative density of a liquid? Relative density of a liquid will not be density of the liquid to the density of water. So because solids and liquid are best compared using water. And so that's why the relative density of a solid will be the density of the solid over the density of water. But relative density of a liquid will be the density of the liquid over density of water. Take note, relative density can also be the mass of the solid to the mass of equal volume of water. Now, all of these are equations that are needed in our calculations. So, relative density can also be the mass of the solid over the mass of equal volume of water. Now, if all of these are okay, now I want you to note this, very important. Note this, that density equals mass over volume. If density equals mass over volume, it means that density is directly proportional. So that means that density is proportional to mass and is inversely proportional to volume. So if it's inversely proportional to volume, I want you to take note of this. When we are not dealing with relative density in terms of mass, watch, we say the mass of the solid to the mass of equal volume in water. So watch about this, density of the solid to density of water. So you see that it's corresponding mass, density, water, density of water. So, but when it comes to volume, in terms of volume, relative density is volume of water over the volume of the solid, or the volume of the solid rather. So watch, it's different from the way that density is expressed, and it's different from the way mass is expressed. I can still give you another in terms of height, relative density. Now remember, volume is equal to area times height. So volume is proportional to height. So I will say relative density equals height in water over height in a liquid. Very, very important. So if all of these are known, various forms in which relative density can be asked, you can tackle them. Why? Because you have a knowledge of all of this. I'll be showing you some questions where we'll know how to solve relative densities and how to solve densities, and applying all of these formulas as we go. Now take note, relative density can also be called specific gravity. Relative density can also be called specific gravity. And take note, what about specific gravity? It has no SI unit. Remember, I told you that the SI unit for density is kilogram per meters cube, but relative density has no SI unit. So relative density can also be called specific gravity. Now, there's what we call density of a mixture. That's what we call density of a mixture. What is density of a mixture? The density of a mixture, let's assume that the mass of a mixture, or a mixture contains mass A and B. And this mass A and B has volume A and volume B and volume B. So therefore, the density of the mixture, which is AB, is equals the mass of A plus the volume, the mass of A plus the mass of B over the volume of A plus the volume of B. This is the formula to solve your density of a mixture. So if a mixture consists of various components and they have their masses and their volume, what you simply do is to add up the masses all over, then the additions of the volume. That's how we solve questions involving relative densities of mixtures. Now we'll be looking at questions as regards density. Thank you. Okay, now we'll be looking at some examples from SSCE, UTME, and post-UTME questions. And so, question number one says, or example one says, a mass of an object 35 gram takes up 7 cm cube of space. Calculate the density. Very plain a question. and easy to solve. So number one, density is equals mass over volume. Then what is density? Density is equals mass is 35 grams over what is volume? 7 cm cube. So density is now equal to 5 gram per cm cube. Now I could maintain my unit, not converting to kilogram and meters cube. Why? Because density can either be in kilogram per meters cube or in gram per cm cube. So there is no need to convert back to this case. Why? Because this unit, the cm cube and the grams, they work together. But if it was kilogram against cm cube, I would have converted from my cm cube to my meters cube. That leaves us with this point, which is very important, that 1 gram per cm cube is equivalent to 1000 kilogram per meters cube. Take note of this and let this be in the front of your heart, that 1 gram per cm cube is equivalent to 1000 kilogram per meters cube. So I have 5 gram per cm cube. If I want to convert it now to kilogram per meters cube, it will become 5000 kilogram per meters cube. So that's solution to question number one. Now let's see question number two. Question number two says, cold oil of volume 600 cm cube has a density of 0.9 gram per cm cube. When heated, the density of the oil decreases to 0.6 gram per cm cube. The volume of the heated oil is dashed. Now, there is something about this question. When when the oil was cold, it's like a clump. It comes together. And so the volume it occupies is not as when it spreads when heated. So you can have a clump of oil in a fry pan, but on heating, that oil spreads. So we cannot say that if cold, the volume reduces, but if hot, the volume increases. So when liquid spreads, the volume it occupies increases, unlike when the oil is cold. That's why you see that the volume of the oil when cold will not be as when hot. The volume when cold will be lesser than when hot. So when I'm done solving, you realize that the volume of the heated oil will be more than the volume of the cold oil. But the density of the cold oil will be greater than the density of the hot oil. That is because you know that density is equals mass over volume. So it means that density and volume, they are inversely related. So if volume increases, density decreases. Then if volume decreases, density increases. But there is something about this question that is constant. What is it? Is the mass. The mass of the cold oil is the same as the mass of the hot oil. Remember, the law of conservation of mass says that matter is neither created nor destroyed, but can change from one form to another. What has happened is that solid or a semi-solid has now become liquid. Ice melts to water. The mass of the ice is the same as the mass of the water. So it means in this question, the mass is constant. So I can say here that density of cold oil is equals mass of cold oil over volume of cold oil, and the density of hot oil is equals mass of hot oil over volume of hot oil. If mass is constant, if the mass of cold equals mass of hot, if the mass of the cold oil equals mass of the hot oil, what are we going to be having? Now, if you know this, mass is equals density times volume. mass is equals density times volume. So the mass of coal will be density of coal oil times volume of coal oil is equal to density of hot oil times the volume of the hot oil. So that becomes the way we solve the question. Now, what's the density of the coal oil? Density of the coal oil is 0.9. So we have 0.9 times. What's the volume of coal oil? The volume of coal oil is 600. That is equal to the density of the hot oil is 0.6. That's 0.6 times the volume of the hot oil. So to solve this question in full, we now have the volume of the hot oil is equal, the volume of the hot oil is equal 0.9 times 600 divided by 0.6. So it becomes 0.9 times 600 over 0.6. Now, if you take this way, you add this there, then you take this cancel out this, then you take this cancel out this. So the volume of the hot oil is equals 900 cm cube. That becomes the answer to this. The answer is 900 cm3. So you see that the volume of the hot oil is greater than the volume of the cold oil. Why? Because on heating, it has occupied more space. Now let's look at example 3. Example 3 says a specific gravity bottle. A specific gravity bottle, meaning a relative density bottle. Another name for a specific gravity bottle is called a relative density bottle or a pygnometer or a pygnometer. This is another name for a relative density bottle, which is also called a specific gravity bottle. What is this instrument used for? It's used for determining the relative density of a liquid. That's what it's used for. So let's see the question now. The question says that a relative density bottle of mass 20 gram weighs, so mass of bottle is equals 20 grams. Then we have, that's when the bottle is empty, is 20 grams. Then it weighs 28 grams when filled with water. So mass of bottle plus mass of water equals 28 grams. Therefore, it means that I can tell you what is the mass of water. So mass of water is equals 28 minus mass of bottle. So the mass of water is equals 28 minus 20. So which is equals 8 grams. So the mass of water is 8 grams. So let's continue with the question. It says mass 20 grams, weighs 28 when filled with water, and 30 when filled with a liquid of P. So now I will say mass of bottle plus mass of liquid P, mass of liquid P is equals 30 grams. Is equals 30 grams. So what is now mass of liquid P? Mass of liquid P will be equal to 30 grams minus mass of bottle. So mass of liquid P is equals 30 grams minus mass of bottle is 20 grams minus 20 grams. So mass of liquid P is now equals 10 grams. Now I have mass of liquid 10 grams. I have mass of water as 8 grams. My question says that we should calculate the relative density of the liquid. So what is relative density of the liquid? Relative density of the liquid P will be equal to mass of liquid P over mass of water. So that becomes, the answer to this will not be mass of liquid P is 10 over the mass of water is 8. So relative density of P will not be 1.25. Remember, relative density has no SI unit. Now let's see question number 4. Question number 4 is a very important question. It's a question you can see in your theory, you can see it in your OBJ. It's a very confusing question. It says oil of mass 0.5 grams. Now take note of your SI units. 0.5 grams and relative density of 0.5 forms a thing of area 0.25 meters square. So this does not agree with this. So one of these two must change. So it's either I'm changing grams to kilograms to suit meter square, or I'm changing meter square to suit grams to centimeter square. So now on a surface of water, full stop, the thickness of the oil film is dashed. Now, this is a question that let's show this solution. Density is equals mass over volume. Now remember, what is volume? Volume is equals area times thickness. Take note of this. Volume equals area times thickness. So therefore, area times thickness is volume. It can be area times height. That height is taken as thickness. So density is equals mass over area times thickness. That's density. So now remember, we have density here, but what was given us was relative density. Relative density. Take note of this. The oil of mass this and relative density this. So they gave us relative density of the oil, not density of the oil. So now I will say relative density of oil is equals density of oil over density of water. This is a relationship or a formula that relates density of a liquid to the density of water in terms of relative density of the liquid. So now what's the relative density of oil? Is 0.5. So 0.5 is equals the density of oil over the density of water. Now take note, I want to convert this to kilogram. Hence, I will not work with 1 gram per cm cube for water. Remember, the density of water is either 1 gram per cm cube or 1,000 kilogram per meters cube. So, if I'm converting this to kilograms, it means I will not use this 1 gram per cm cube for water. I will use 1,000 kilogram per cm cube. So here becomes 1,000 kilogram per meters cube. So on solving, density of oil will now be equal to 0.5 times 1,000. So the density of oil is 500 kilogram per meters cube. Now, on getting density of oil, it means I cannot apply this formula. Now, this becomes, so recall. What are we recalling? Density of oil is equals mass of oil over area times thickness. So if you take it up here, what is our density of oil? The density of oil is 500. So it becomes 500 is equals, what is the mass of oil? It was supposed to be 0.5. 0.5, convert it to kilogram. It means we have to divide by 1,000. So I have 0.5 divided by 1,000. It becomes 0.0005. That becomes the answer to this. Then all over, I have area, which is 0.25. Put my 500 here, is equal to this 0.25 times what is our thickness. That's what we are looking for. So take this off. You have 500 times 0.25 times thickness. Everything is equal to 5 times 10 raised to the power minus 4. Now what do we have as thickness? So thickness will not be equal to 5 times 10 raised to the power minus 4 all over 500 times 0.25. So the thickness will not be this, cancels out this, then we have 10 raised to the power minus 4 over, this will not be 2.5 times 10 raised to the power minus 3. So I have thickness will not be 10 raised to the power minus 4 over 2.5 then times that's plus 3. So thickness will now be 10 raised to the power minus 1 over 2.5. That will now be 0.1 over 2.5. So if our thickness will not be equal to, then you have 1 over 2.5, 1 over 25, which equals 0.04. So thickness is equal to thickness. Thickness is equal to 0.04 meters. That becomes the answer for thickness, 0.04 meters. Thank you. Now let's see question number 5. Question number 5 says an empty 60 liters petrol tank. I want you to know this, that 60 liters is equal, I want you to know that 1 liter is equal to 1 dm cube and is equal to 0.001 meters cube. Take note of this. 1 liter equals 1 dm cube equals 0.001 meters cube. So therefore 60 liters is equals 60 dm cube and is equals 60 divided by 60 divided by 1000, which is something as 0.06 meters cube. So take note of this. This is very, very important in this conversion. Not knowing this could result to a wrong answer even after solution. So we said an empty 60 liters. So I've converted this already to meters cube, which is our normal standard for solving. So an empty 60-liter petrol tank has a mass of 10 kg. Full stop. If its mass when filled of fuel of relative density 7.2. Now, it was still giving me relative density of fuel, not density of fuel. But I will always need the density of fuel in order to solve. So when relative density is given me, it's my job to find density from relative density of the liquid that was given. So I know that relative density of fuel is equal to density of fuel over density of water. Remember, I will always compare a liquid with water. I will always compare a solid with water. That's what relative density does. It's a comparison. So now, what is this now? Relative density of fuel, relative density of fuel, relative density of fuel. What's our relative density of fuel? Is 0.72 is equals density of fuel is unknown over density of water. What's density of water? 1000 kilogram per meters cube. So what is now the density of fuel? The density of fuel is now 0.72 times 1000. What is now density of fuel? Density of fuel is now equal 720 kilogram per meters cube. So this is not the density of the fuel. Now, if we have the density of the fuel, now remember that we have the volume of the tank. What about the volume of the tank? If you go to a fuel station with a 20-liter gallon or a 20-liter container, when you want to fill the gallon, the amount of volume of liquid you can buy is the same amount of what the volume of the container you took there will be. So it means a 20-liter empty tank will take 20 liter of fuel, while a 60-liter empty tank will definitely take, when filled up, will definitely take a 60 liter of fuel. So that is one of the ideas you need to solve this question. Now remember, we are looking for its mass when full with fuel. So it means if I solve for the mass of the fuel, I will add it to the mass of the container. Remember again, if I solve for the mass of the fuel, I will add it to the mass of the container. That will not be the total mass when the container is filled. So now I already know what is the mass of the empty container, which is 10. It's my job now to look for the mass of the fuel. Then when it is filled in the container, the total mass will not be Mass of the empty tank plus mass of the fuel. So what is now the mass of the fuel? The mass of the fuel can be gotten because I already have the density of the fuel. So density of fuel equals mass of fuel over volume of fuel. So mass of fuel is equals density of fuel times the volume of fuel. What is now this? The mass of fuel equals density of fuel is 720 times what is the volume of the fuel? The volume of the fuel is the volume of the container. And what's the volume of the container? Remember, 60 liters has been converted to meters cube, which is 0.06 times 0.06. So therefore, the mass of fuel will be equal to 43.2 kilogram. That becomes the mass of fuel. Now, look at where the question is. Now, the question says, its mass when filled or when full of fuel. So, when full of fuel, when full with fuel, its mass is, will be given as mass of tank when empty plus mass of fuel. What is the mass of tank when empty? 10 kilograms. So it becomes 10 plus, what is the mass of fuel? 43.2. 43.2. So therefore, the answer becomes 53.2 kilograms. So the answer to this question is 53.2 kilograms. That's the correct answer. Thank you. Now let's look at question number 6 and question 7 as regards density and relative density. A liquid of volume 2 meters cube and density 1 times 10 raised to power 3 kilogram per meters cube is mixed with 3 meters cube of another liquid of density 8 times 10 raised to power 3 kilogram per meters cube. Calculate the density of the mixture. Now remember, the density of liquid 1 and 2 is equal to the mass of 1 plus the mass of 2 over the volume of 1 plus the volume of 2. So let this be the volume of 1 and let this be the volume of 2. Why this is the density of 1 and this is the density of 2. Now the problem is they did not give us the mass of the liquids. So I cannot just approach the question once. So what will I do? I have to solve for the mass with those quantities I have or those factors I have. So it means the density of 1 is equal to mass of 1 over volume of 1. So therefore, the mass of 1 is density of 1 times volume of 1. So mass of 1 is equals the density of 1 is 1 times 10 raised to 3 times the volume of 1 is 2. So the mass of 1 is equals 2 times 10 raised to 3 kg. What about of 2? Density of 2 is equals to mass of 2 over volume of 2. So what is the mass of 2? The mass of 2 is density of 2 times volume of 2. The mass of 2 is equals, what's the density of 2? Is 8 times 10 raised to 3 times what's the volume of 2 is 3. So that becomes the mass of 2 is equals, that's 24 times 10 raised to power 3, which is same thing as mass of 2 is equals 2.4 times 10 raised to power 4 kilograms. Now I have the mass of 1 and the mass of 2. Look at them here. The mass of 1 and the mass of 2. Now I can approach this question. Density of the mixture, which is 1 and 2, is equal to, what's the mass of 1? The mass of 1 is 2 times 10 raised to 3 plus the mass of 2 is 2.4 times 10 raised to 3, raised to 4 over, what is the volume of 1? The volume of 1 is 3. The volume of 1 is 2 plus the volume of 2 is 3. So now the density of 1 and 2 will be equal to, now this is the same thing as saying 2,000 plus this is the same thing as saying 24,000. So over 5. So the density of 1 and 2, that's the density of the mixture, will be, that will be 26,000 over 5, which will now be 5200. So the answer is 5,200 kilogram per meters cube. That becomes the answer to this question. Thank you. Let's look at example 7. Example 7 is a very tricky question, and I want your eyes to look at it very well. A rectangular block of wood floats in water with 2/3, that's 2 over 3, of its volume immersed. When placed, now watch this, this was in water. When placed in another liquid, it flows with half of its volume immersed. Calculate the relative density of the liquid. Now, please take note. This is for number 7. Take note of this. We said that relative density of a solid is equals mass of the solid over mass of equal volume of water. We said relative density of a solid can still be density of the solid over density of water. We said relative density of a liquid is equals density of a liquid over density of water. We now said relative density in terms of volume will be equals volume in water over volume of the solid. So you see that in terms of volume, it is turned. It can be relative density is volume of water over volume in a liquid. So this is what I will use to solve this question. So I can show it back to you that in water, it is 2/3 that was immersed. Now, it is always the portion in the water, not the portion out of the water. Then in another liquid, it is half of its volume that was immersed. So it means I can say this here, volume in water is equals 2 over 3. Volume in liquid equals 1 over 2. Therefore, relative density is equals volume in water over volume in liquid. Relative density is equals volume in water is 2 over 3, divide volume in liquid is 1 over 2. Relative density becomes 2 over 3 times 2 over 1. Relative density equals 4 over 3. Mind you, some sites and some question bank solved it wrongly and got 3 over 4. But that isn't the correct way to solve. The correct way to solve is volume in water over volume in liquid. Remember, is the portion that was immersed that concerns us, not the portion that is outside the liquid. Thank you.